Our exhibition is on the Georgia Tech VIP East Stadium project. Now, the East Stadium project is a collaboration between the students at Georgia Tech, local Atlanta universities, and our school. Now, the main point of the East Stadium project is to create a smartphone app to keep fans engaged at Georgia Tech home football games through the use of statistics, trivia, and real-time video clips. Now, our portion of the VIP project is to develop a way to locate and track objects on the football field, whether it's like a yard marker or even the football itself. To talk a little bit about this,
Okay, so what this is our test bed, and what we're using this for is to calculate the X, Y, and Z coordinates of this object, and in this case it's a corner reflector. And how a corner reflector works is when you send light at it, it reflects the light back at the same angle. So for example, if you took a picture with a flash camera, the image would come back with a glare where the corner reflector was, like right here. And for our cameras, we would have to have at least 3 cameras. If we had 2, then we can only be able to calculate 2 coordinates instead of the X, Y, and Z. And for each camera, we have to know 6 pieces of information. First, the X, Y, and Z coordinates of each camera, and then the X, Y, and Z coordinates of the direction cosine of the line it makes. And Josh could probably explain all that more.
Okay, well, here is the position of the camera, and the corner reflector would be located here at the origin. And this dark blue line goes from the camera to the corner reflector, and so you could see it better, I'll orient the program. Okay. Now, we use the cosines to find the direction of this line, and the angles we measure the cosines of are the angles between this dark blue line here and the X, Y, and Z axes, which are represented by the yellow, the red, and the pink lines. Now this is only for one camera. If there are multiple cameras, we'd have multiple dark blue lines coming from different points on this grid here, and each one will have its own independent information. And here to tell you about the math is Dan.
So to find the location of the object, or the corner reflector in this case, we need to find where the lines intersect, or in the case of error, where they come closest to each other. Now to do that, we need to find every individual equation of the line from the camera to the corner reflector. So here we have the equation of the line for camera 1, 2, and 3. We need to find 6 variables, the X, Y, and Z being the location of the camera, which we control, and then alpha 1, beta 1, and gamma 1, which are the direction cosines. Now, to find the direction cosines, we need to go to the camera's image. Now, using the relationship between the pixel distance from the center of the image to the corner reflector and the distance in inches from the backing of the test bed, we were able to find out 2 of the direction cosines. And from there, to find the 3rd direction cosine, we just use Pythagorean theorem. So in reality, we only need to find 3 or 5 variables. Now from there, once we know all 3 of the direction cosines, we can relate this pixel region here to this specific equation of the line, or these 3 specific direction cosines. It's your own unique equation of the line, and so any object that falls in that pixel region will lie anywhere along this line, extending far beyond the backing of that opposite side of the board. Now, the biggest issue we're probably going to run into are skew lines, and that comes into play due to measurement errors. Now, that's what we're currently working on, and the most plausible reason that course of action at this point is to find where the lines meet closest, and then get sort of an average of the center of the area to get an accurate estimate of where the location of the corner reflector is. And that is our presentation.